Welcome to supply chain management. We're going to switch gears a little bit and we're going to talk about a different kind of forecasting method. It is the exponential smoothing. Now, the exponential smoothing assumes that we are currently in a certain period t, and we calculated the forecast for the previous period, so t minus 1. So we know what we forecasted for the previous period. And we also know what we sold, so what were the actual sales for the previous period. So we have these two data points, and based on what we forecasted in the previous period and what we actually sold, then we would use this formula to calculate this new forecast for the current period. So here's the formula, and let's assume that we want to forecast September. We are at the very beginning of September, and what we're going to do is we're going to look at the forecast of the previous month. So September minus 1 would be August. And to this forecast, we're going to add a percentage. Alpha is called, it's a smoothing constant. It's this Greek letter here in pink. And it's a number between 0 and 1. So it's a percentage. And what to the previous forecast, so to the forecast of August, we're going to add a percentage of the difference between what we sold in August and what we forecasted in August. So how is like the gap, we're taking a percentage of the error that we had for the previous month. Therefore, we can say that the smoothing constant alpha expresses how much our forecast will react the observed differences, and the differences being what we forecasted versus what actually happened in the previous period. Because alpha is a percentage, 0 to 100, you can imagine that a low alpha, so a number is close to 0, will have a small reaction to these differences, so you'll take almost 0% of this difference. And a high alpha will actually create a strong reaction to the differences. You're going to take almost the entire difference if you're closer to 1. So if alpha is closer to 1, it means that we are going to consider almost entirely this difference between forecast and actuals for the previous period. Let's see. Quick knowledge check for you to understand the function of alpha. What happens in this formula here if alpha equals 0? Note that alpha here would have to, when you don't have a sign, means that you're multiplying alpha by this difference. Think about it a second. You can check that your answer here at the bottom, the answer is upside down. Now let's look also at an example. Let's put things in practice so the theory becomes a bit more clear. We're going back to our juice factory. Here is the same sales that we had before. You can see the downward trend from February to June, so nothing different there. What we also know is that we forecasted for January to be 2,055 units. So you see, well, we're going to try to calculate two exponential smoothing, one with an alpha of 0.2 and another one with alpha 0.8. So we can see how the forecast changes depending on how we change the alpha. But in both cases, we're saying January, the original forecast was 2,055 units, and what we actually sold was 1,988. So we definitely over forecasted, right? The sales didn't come out as high as we hoped. So how do we calculate the exponential smoothing in these two cases? Here we go. If here we have the details with using alpha being 0.8, so how we calculated this number here, and this is what we do. We say the forecast for February were equal of the forecast we had in January, the previous month, t minus 1, which was 2055, plus the alpha, in this case we are using 0.8, multiplied by what we sold in January, 1988, minus what we forecasted in January. Again, of course, is 2,055 units. So this number is repeated twice in this formula. And if you do the math, you'll find out that the resulting forecast, so the exponential smoothing forecast using alpha of 0.8 is 2001 unit. And here is where it is. Once you have this forecast, of course, if you want, you can, and the new actuals, then you can also forecast March, April, and so forth and so on. And you can do the same for alpha being 0.2, and you see that these are the numbers that comes out. As always, it is important to graph, right, the forecast and the actual demand that we had to understand if we are on the right track. And here we have the orange line being the blue line being the actual demand, so the first column here, so what we actually sold. The orange line is the forecast using alpha of 0.2, and the gray line is our forecast using alpha of 0.8. Now you see, with a larger alpha, this gray line is much closer to the blue line, so what the actuals, what we actually sold, compared to the orange line. So compared to using the alpha of 0.2. So a larger alpha reacts more strongly to the changes in strand. This was a brief video. We talked about exponential smoothing forecasting, and I'll leave you with this knowledge check. And I'm asking you to select the forecast parameter values that would comparably yield smaller or larger reaction to changes. So do you think that in this case you have smaller reaction to changes if you use 3 months average or a 5 months average? If you use a 20/80 split or a 40/60 split? And the third case is if you use an alpha 0.3 or an alpha 0.7. These are common questions for the exam, so see if you can figure this out, and the answers are upside down here at the bottom of the slide.